Hello everyone. Today's session will concentrate on the concept of central tendency with respect to univariate data analysis. So let's first see what is central tendency. So central tendency basically provides a summary or condensation of data. So when you have really lot of data in your data analysis, you have implemented your algorithm, right? You will be having lots of data. So so data analysis becomes very complex when you have lots of data, especially when you are implemented your algorithm and you're trying to do some kind of graphical analysis. You cannot really represent all the 10,000 sets or millions of data on your graph and do the analysis. So the best way here is to choose central tendency, where you're going to condense the data so that the analysis becomes easy and simple. So basically this concept of central tendency explains the characteristics of a data just with a summary, and therefore you can use that for further comparisons. So most of the since we are going to condense the data, now the question is how you're going to condense. So normally the tendency here is to concentrate the values normally in the central location. Okay, so some kind of average of the data would be taken in order to do the condensation of the data. So we also call this as first order of measures. And some popular central tendency measures are mean, median, mode, which you might have studied in your school days. The same concept here. In mean, we are going to also discuss about weighted mean and geometric mean. Now let's discuss all these three different central tendency measures. So coming to the first one, mean. Mean is nothing but arithmetic average, which is a measure of central tendency which represents the center of the data set. So it represents basically the center of the data set. The most common measure is average income or average traffic. So suppose you have taken the income of some 1,000 employees. So you want to take the mean of that. So that would be the average, right? So basically, how do you obtain the mean? You add up all the data and divide by the number of observations. So this is a simple formula. Suppose I have some n observations, and these are the different n quantities that I have, x1, x2, xn. So just add it up and divide by number of observations. Or in term of summation, you can say 1 by n summation I is equal to 1 to n xi, where I ranges from 1 to n. Or a simple example, suppose I have three quantities like this. The mean is nothing but just add it up, divide by 3, you get the mean. So coming to the problems in mean. Now this is a very easy way of doing a condensation. You have taken the average of, let's say I have some 10 numbers, you have taken the average and you have calculated the mean. Now the problems in mean is it is extremely sensitive to noise, right? Even why? Because even small changes in the input will affect the output drastically. Suppose there is some kind of noise in the parameter x1, right? That value would be calculated in the average, and therefore the output will get affected. And hence normally what is done is top 2% is cut off, and then the mean is calculated for a large data set. So when you are having really large data set in, like, let's say I have 10,000 values, the top 2% we are not going to consider, and just take the rest of the 98% and calculate the mean. So there are again two types of mean, weighted mean and geometric mean. Now weighted mean is, this is a formula. So basically what we do is we give weightage to the items, unlike the previous arithmetic mean. What we discussed here is just the arithmetic mean, where each quantity is having equal weightage. Okay, so what happens is, even suppose there is noise in x1, since I've given equal weightage to all, even noise is considered equally. So to overcome that problem, you can also go for weighted mean, where we will give different importance to different items. Okay, so that we can do by giving weightage. Suppose x1, suppose there is, you want to give less importance due to randomness, you can give w1 value lesser w1 value. Suppose x2 is more, having more information, you can give more weight to w2. So the basic formula for calculating the weighted mean is, you just multiply x1, x2, xn up to xn are the different values that you have, number of observations that you have. So multiply each observation with a weighted value, give the weights as you choose your priority, or how do you want to give importance to your items, and divide by the number of weight. So this is a formula of weighted mean. Coming to the next one, geometric mean. Now the geometric mean, so the same example, suppose I have x1, x2 up to xn. Suppose these are the n values or observations I have. So geometric mean is nth root of the product of n items. So what you do is take the product of this x1 into x2 into x3 into up to xn, and then take the root of n, that is a take the root with respect nth root of the product of these n items. So that is the formula of geometric mean. Symbolically, how do you represent as x1 into x2 up to xn is represented symbolically by this product symbol where of xi, where I ranges from 1 to n. The overall value you take the nth root, that is 1 by n. Now suppose I have two values x and 8. The geometric mean of this is multiply 6 and 8 and then take the root of that with 2. Why 2? Because I have only two data sets here. Two observations here or two values here. So square root of 48 would be the geometric mean. Now suppose I am doing geometric mean for complex cases. I have a really large complex case. Then the formula for calculating the complex or larger data sets is you take the logarithm of each data set. Each value log x1 plus log x2 plus log xn divided by the number of observation. Okay, and then for this quantity again you apply the anti-log. Why you have to apply anti-log? Because I have applied log for each one. Right here what we did is, since we applied log for each quantity, you have to take a anti-log again. So that would be the geometric mean for larger data sets which are complex. So coming to the next one, that is median. Now median is another way of central tendency calculation where the middle value in the distribution is called as a median. So median is basically the middle value. Suppose with an example we'll understand. Suppose these are the values that I have. So which is the middle value here? The number of values here are odd. I have 7 values here. So this is the middle value. So the median is 6 in this case. Now in this case I have even number of values, right? I have 8 quantities. So I don't have exactly middle number. So what we do is we take the average of the two middle numbers. 4 plus 5 divided by 2, 4.5. So how do you calculate median is nothing but the middle value in the distribution. If the total number of items in the distribution is odd, take the middle value as median. If the total number of items in the distribution is even, then take the average of the two items in the center as median. So basically median is a value where you divide it into two equal halves, where you divide xi into two equal halves. This is the lower half, this is the upper half, and median will be in between. Okay, so median would separate the lower half and the upper half. So in terms of formula, this is how you can calculate the median for your data set. L1 plus n by 2 minus Cf by f into I. So where n is the number of observations. Okay, so since we are dividing it by 2, we take n by 2 items. Okay, then I is the class interval of the median class. So that is number of I is equal to 1 to n. So for each it is the class interval, and L1 is the lower limit of the median class, and f is the frequency of the median class, and Cf is the cumulative frequency of all the classes preceding the median. So we do not have any problems with respect to this. So it's just enough you just know this formula. Now coming to the next one, that is mode. So mode is the most frequently occurring value in the data set. Okay, so mode is the most frequently occurring value in the data set. Suppose this is the values that I am having. So which are the most frequently occurring? 3 and 9. Both are equally occurring. 3 is repeated 3 times, 9 is repeating 3 times, and therefore there are two modes in this data set, 3 and 9. In this data set you can see that there is no repetition, therefore there is no mode in this data set. Now coming to this one, you can see that 2 is repeated 2 times. That is the highest frequency, therefore the mode is 2. Okay, so mode is basically the value that occurs most frequently in the data set. And remember this, it is only for discrete data. These are all discrete data. You cannot have mode for continuous data. Continuous data means something like you have continuous values. In continuous values there are no repeated values, so that's why you don't have mode in the continuous data. So basically what is the procedure for calculating the mode is, first calculate represent all your values in the data set, find out which is having the highest frequency, that is nothing but the mode. Now again in this you can say that data set, based upon this mode you have three classifications of data set: unimodal, bimodal and trimodal, based upon the modes. Okay, so a data set with mode 1, for example this one, this is unimodal. Data set with mode 2, this one, it is that means which is having which is repeating 2 times, that is mode 2. Data set which is repeating 3 times, it's called as a mode 3. So to have a clear differentiation, let's see this example: unimodal versus bimodal versus trimodal data set. Now this is a classification of data set based upon the modes. Okay, so unimodal data set having one frequency that mostly occurs within the data set. For example, I have values here 5, 4, 3, 3, 6, 7. Here mode 3 is the mode here is 3 is a value which is occurring more frequently, and therefore this is unimodal. In the next example, you can see that both 4 and 3 are occurring uh, with a frequency of 2, and therefore the mode here so the mode for this data set is 3 and 4, therefore this is a bimodal. So bimodal is a data set having two frequencies that mostly occurs within the data set. Trimodal is 3 data set having three frequencies that occurs most frequently. For example, here 4 is repeated 2 times, 3 is repeated 2 times, 6 is repeated 2 times. Therefore the mode is 3, 4, 6. Therefore this is trimodal or multimodal. So in the graphical representation is like this. Unimodal you will have just one peak. In bimodal we will have two peaks which are same. In trimodal you have three peaks which are same. Okay, it is also called as multimodal because multimodal is nothing but data set having frequencies 3 or more. Now coming to the next concept, dispersion. Now this is all about the spread out. Okay, how is the spread of the data around the central frequency, central tendency? What is central tendency? Mean, median, mode. So how is the spread of data around these mean, median, mode? That is nothing but dispersion. And here we have these four concepts in dispersion: range, variance, standard deviation, and standard error. Now this we call it as second order measures. Okay, mean, median, mode is called as first order measure. Range, variance, standard deviation, standard error are called as second order measures. Now these are the most common measures of dispersion data. This is normally we use it for measuring the dispersion data. Let's see each one. Range. Now range is a difference between maximum and minimum value of a given list of data. So suppose here in this example, right, what is the range here? The maximum value is 7, minimum value is 5. So range is 7 minus 5. Okay, so range is the difference between maximum and minimum value. Standard deviation. Now standard deviation is the average distance from mean of data set to each point. So what is the distance from the mean to each point? So we will see some problems with respect to this in the next session. So basically how do we calculate standard deviation is, for each value we subtract with the mean. Each value is xi. Suppose I have the xi is the observations or values that I have in my data set. So I have n observations and xi is the observation. So x1, x2 up to xn. So for each item I'm going to subtract with the mean and then take the square, divide that by number of observations minus 1, and then totally take the square root. So that is a standard deviation formula. This you must have done in statistics in your school days, the same concept. So basically this would give a standard deviation for each one. For each value we are going to calculate the standard deviation. Now there's one more also concept, second order range, that is quartiles or interquartile range. Now this is very convenient to subdivide the data set using the coordinates. Percentile is a very important concept here. Most of your students would be familiar with this. You must be knowing the difference between percentage and percentile, the same concept here. So percentile is all about data that are less than the coordinates by some percentage of total value. Right? So kth percentile means what? K percent of data lies at or below xi. Right? If you say kth percentile, that means k percent of data is at xi or below xi. Suppose I have a 50th percentile, median with 50th percentile is denoted as Q0.5. 20th percentile is the first quartile, 75th percentile is a third quartile, 50th percentile is a second quartile. Right? So how do you calculate the IQR? We will do problems on this later in the next session. Basically it's the difference between the third quartile and the first quartile. Okay, so interquartile range is the difference between Q3 and Q1. Next, outliers also normally the values as we have discussed which is falling apart, right? And it should fall apart at least by an amount of 1.5 into IQR. So you have already calculated your IQR, multiply that 1.5. So that would give us the outlier. So that is the outlier definition. So interquartile percentage, how do you calculate is Q3 minus Q1. Outliers are normally they have to be apart by 1.5 into IQR. So we will do problems with respect to this in the next session. So that's it for today's session. So today's session we had a quick revision of all the central tendency concepts, mean, median, mode, and we also discussed about the second order ranges, range, variance, standard deviation. The problems we will see in the next session. Thank you so much, and please subscribe to the channel. Thank you.